Hi there, my name is Dave Aaron, and welcome to Data Dives Episode 2. Today, we're going to dive into incremental models within dbt and show you how to speed up those data pipelines. Now, if you're unfamiliar with dbt, it is an extremely helpful data transformation tool, allowing you to build data pipelines in a very modular and composable way. It's a favorite across analytics engineers everywhere, and I highly recommend you dive into it further. Why is having fast data pipelines important? There are a number of reasons. The first is that it'll allow you to update your data in a more timely fashion, providing insights that are more recent and allow the business to react faster to recent performance. Second, it allows you and your team to iterate and develop faster, whether creating new data sets and functionality or making tweaks to existing data products. Having pipelines that run quickly is really going to speed up your development process. It will also help you resolve issues faster, leading to better trust with your stakeholders. Third, having efficient data pipelines will save you costs against your data warehouse. If you have pipelines that process a smaller amount of data, that's going to result in less compute spend. And there are other benefits, including reducing latency for other applications that are running on the same infrastructure as your data pipelines. So let's break down how incremental models work. On a normal run, only the recent or changed data will get processed, while the rest of the data remains in the model. In order to rebuild your entire model, you can perform a full refresh occasionally. And how do you find models that are going to be good candidates to make incremental? First, if they're taking a long time to run, that's usually a good sign that there should be some optimizations to be made. Second, if the source tables that are populating your model are very large, and if they have historical data that either doesn't change or changes infrequently enough that if you miss one of the changes, it's not a big deal to the overall model itself. Now, before we get too deep into how incremental models work, I really want to caveat that incremental models are a very hard topic to understand. So please don't feel discouraged if it doesn't make sense right away. It will click, and when it does, it's going to be very worth it. So let's visualize what it actually looks like for an incremental model to run incrementally. If on the left-hand side we have our source data, which goes back from an earliest date all the way through to today, what we want to establish is a recent time period where we want the data to recrunch every single run. This is usually best to be just 2 to 3 days of recent data. So only data in that blue range over the last couple days is actually going to be recrunched. And there may be some of that data that is overlapped with what's currently in your dbt model. So what dbt will do is take the newer data, the data in blue, overwrite any of that data in red that you see there, and combine it with the existing dbt model in yellow to produce your updated dbt model on the far right. So again, it's not going to touch any data that is prior to that blue. That's all going to remain the same, but it's going to append the data in blue, the newest couple of days, and create your final model. A full run is much more straightforward. It's going to use the full history of source data and overwrite any data that's in your existing dbt model to populate your final updated dbt model. Okay, so we're in dbt, and table bike trip is the original model that we're going to look to optimize. So this is configured like a pretty normal dbt model. It's set to a table materialization, so it's going to build as a table. It's pulling results from this table in Snowflake called trips clean, and it's just doing some very light transformations, pulling a handful of columns, doing a distance calculation, and a little bit of math to figure out how old the subscriber was at the time of the trip. So what we want to do is try this model out as an incremental model instead. So what we'll do is we'll have this table bike trip incremental version, and we want to make a few changes to actually make this run incrementally. The first thing we want to do is change the materialization. So rather than a table, we're going to set this to run as incremental. The next thing we want to do is set a unique key. which is going to serve as the primary key for this incremental model. And it's going to help ensure that dbt does not insert duplicate rows when it runs incrementally. That if it finds the same row in its processing, it's going to overwrite the existing data set rather than creating a new entry. So the unique key we're going to use for this is the trip ID, which is the primary key we want for this model. Now, the next thing we want to do is put in a code snippet that is only going to run if the model is being run incrementally. Now, this is what this code snippet will look like. If is incremental, then it's going to run the piece of code in this snippet. If it's being run on full, it's going to exclude this clause. So what we're going to do here is make sure that if it's running incrementally, we want to restrict the records that it's going to be updating to only be the last 3 days. So in other words, we want to limit this to where a.start time as a date is greater than equal to the current date minus 2. Now this is going to ensure that only the current day and the previous 2 days are going to be recrunched when we run this incrementally. So the way to think about this is if we are doing an incremental run, this where clause is going to show up, and it will be equivalent to if you were to put this where clause right after the from over here. If we're doing a full run and processing the entire data set, then this whole thing is going to be ignored, and it's going to run the identical statement that we were running before in table by trip. Now, the first time dbt runs an incremental model, it needs to process the entire data set. And we can see that it took 1 minute and 20 seconds to do that full run, which is almost identical to the time it took to run table bike trip. And this makes sense because it's essentially doing the same exact operation. So now that it's been built, let's take out that full refresh and run it incrementally and see what happens. Okay, so now it ran in 12.7 seconds. And when we look at the details, we see this number over here, which is 1.5 million. This signifies the number of rows that were actually processed during this incremental run. And for comparison's sake, if we look at the entire data set, we can see that there are actually over 400 million rows. So dbt only processed 1.5 million out of 400 million rows in this incremental run. So in other words, we just cut down the amount of rows processed by over 99.5%. And when it comes to runtime, when we did the full run, we noticed that it took about 1 minute and 20 seconds to run. And when we did the incremental run, it took less than 13 seconds. So right there, we just saw a 6x improvement in runtime of this procedure simply by making it incremental. So the recommended strategy is to use incremental runs as often as you can. When your data is updating frequently, such as every hour or every day, you'll want to use incremental runs to process a smaller amount of data and make those runs go faster. And it's a good idea to supplement that with a full run less frequently. So maybe once a week or once a month. And this will make sure you don't miss any historical data. And there are some complications with incremental models as well. And one of them is what happens if you need to use window functions based on your all-time data. An example of this would be if you needed to calculate the rank of a customer's order. If you do this window function in the incremental run, it's only going to do that window function on the smaller subset of recent data. It's not going to look back fully historically. One way to solve this is to break your model into two, the first of which will run incrementally, and the second of which will run completely. This will make sure that you can still process the bulk of data in an incremental fashion and save that time and resources, while not losing the accuracy and integrity of the data by making sure that the window function runs on your entire data set all the time. Okay, Well, hopefully this was helpful in explaining how incremental models work in dbt and how you can leverage them to really speed up those data pipelines. Thanks for watching and hope to see you next time.